Hello, welcome to my 8th upload for the day. Today, we're going to be doing what exactly the title said. So, before we ended the last video, I explained what an atom actually looks like, and I also explained Schrodinger's cat very poorly. I don't really know where else to start with this, because I have a very limited knowledge of quantum physics, if you can't tell. But, you know, let's just try to fucking do it. Let's try. Let's just try. So, in quantum physics, now, I would try to explain quantum computing, but quantum computing compared to regular computing is just, it's stupidly complicated. Like, I don't even know actual computing, but quantum computing makes actual computing look like addition fucking math. Because instead of bits where you've got a bit like this, say that's a bit, you've got something called a qubit, which I believe is bigger than a bit. I think it's like a collection of data, but kind of put into the size of a bit. We're not even going to build anything. We don't need to build anything. But I'm not sure what a qubit is, but the possibilities of quantum computing are basically infinite, where it could revolutionize computing as a whole to where, you know, sending in information is instantaneous. Like, nowadays it seems like information is instantaneous with computers and shit, but quantum computing, theoretically, it could be way fucking faster, and I find that super interesting. Now, in the last video we talked about what an atom looked like. Say this is the nucleus of the atom, so let's make the nucleus look something more like a nucleus of an atom. Okay, I was looking for... So that's the nucleus, and the little particles that orbit around the atom. You know, the stereotypical atom where you got an atom and then there's shit floating all around it in all sorts of directions. That doesn't actually happen in the darker areas of the atom, because an atom looks kind of like this, where it's darker and then around the outside it's lighter and lighter. From the center it's darker, outside it's lighter. And basically the little particles that are attached to the atom, they're more likely to be in the dark areas than in the gray areas, but they are technically everywhere in this area at once. Because quantum theory, which I've said many times before in the previous video, is basically the explanation of movement of particles, where particles are essentially everywhere and nowhere at once by what, no, not particularly particles, but the things around particles, and some particles, I guess. But, you know, what people also don't know is that there are 12 different particles, and one of those particles is called a graviton, which is recently theorized, where it's the particle that's in charge of gravity. That's pretty fucking neat. Now, we're going to get a little bit out of quantum theory, but we're going to talk about some things, how we know about quantum theory. One of the things we know about quantum theory is because of something called a particle accelerator. Now, a particle accelerator is just essentially a fucking big ring that's... I'm pretty sure it's hundreds of miles across. But in this ring, you've got a particle that's going this way. So say particles going this way, going this way, going this way. So you have a certain particle. Say you've got a negative charged particle. Now, you've got another negative charged particle, but it's going the opposite direction. I don't have anything to show which direction they're going, but just think of them as going in the opposite direction from one another. They collide to each other, going similar to the speed of light, and create new elements, which decay nanoseconds after their creation. I was gonna blow it up just as a joke, but I didn't have anything to blow it up with. But particle acceleration, also known as a mini black hole generator, because so you're throwing fucking particles at each other so fast that you cause a minor rise in temperature called a Kugelblitz, where it's basically so fucking hot that it causes a black hole because of the pressure around there. Now, I'm not sure if I'm not sure if particle accelerators do cause Kugelblitzes, because Kugelblitzes is as hot as the universe was when it first started out, which is the only theoretical time that that's ever happened. Because one thing that people don't understand about the universe is that think of the universe, it wasn't, the creation of the universe wasn't like some big explosion. That's what most people think. Fucking Christ, I was trying to pull something up. It would have been nice. This is why I need to edit videos, is because I would have just had this up and it would have looked a lot more sense. But you're looking at me doing this shit. The universe wasn't an explosion, and just fucking not an explosion, because explosions basically it requires matter and shit. It's just an explosion of matter. It's a propulsion of matter. The universe, how it was created, is that you can't really have an explosion if you don't have any surrounding matter. It's not really an explosion. It's more of an expansion of space all at once. Makes sense? So basically, say you've got something the size of an atom, because atoms have 99.9999% empty space, something like that. All I know is it's like 99.9% empty space. Like I said, I'm not a scientist, and I'm not even very well. Like, I'm researched into this. Like, I've got lots of hours of research into this stuff. But mathematically, I'm not talented in explaining this stuff, and explaining it, like, it's a lot harder for me to wrap my head around it than, say, like an actual quantum physicist or an actual scientist, because the only true way to understand quantum theory, or really science for that matter, is to know it mathematically. It makes a lot more sense to know it mathematically, and a good example is force equals mass times acceleration, which is Newton's second law. Even learning Newton's second law, you can find out it makes a lot more sense understanding it in mathematical form than in real life form, but at the same time you put it to real life form too. It's kind of one, I don't know how to explain it. Like, it helps you better understand the real life form if you see it written down on paper. In my experience. Where are we talking about? The universe fucking expanding all at once. So you gotta think of something going from the size of an atom, so say like that little pixel that I have highlighted right there, instantaneously growing into thousands, if not millions of miles of space. Now, that's pretty fucking quick. And that's in nanoseconds. Hundreds of decimal points. Not decimal points, of zeros. Nanoseconds. how fast it expands. And something called a Kugelblitz could have and probably did happen during that time, where actually might have created a black hole called Ton 16, or not Ton 16, 618, which is the biggest black hole known to humankind. And it essentially has the accumulated mass of 68 million solar masses, which I believe a solar mass is like a solar system size, because the that might be incorrect, because so say this is our solar system. You got 1, 2, 3, 4, 5, 6, 7, 8. Now, say one block is the solar system. That's the width of the black hole. But that's just, I'm talking about length. In total size, it's millions of times bigger. Millions. Can't build it quick enough. But what I was explaining, though, is that this shouldn't be physically possible, because the maximum amount of mass that can be accumulated in one area should only be estimated around 50 solar masses. Remember, Ton 618 is 68 million solar masses. So 18 million solar masses is quite fucking quite a jump. But there's a simple explanation, kind of. So basically, during the birth of the universe, so say this little area within the first nanoseconds of the universe, this little area right here became the universe. And it's not very perfect in size, but whatever. So Big Bang happens, Kugelblitz happens. Due to a Kugelblitz, the pressure built around the area because of heat creates a black hole. Now, because of in these nanoseconds, the black hole that is formed, probably the first or one of the first black holes to ever form, is basically in a tight area of mass. It would just swallow up, say, like these 4 or 5 blocks, and yeah, wrong color, but say it just swallow that much, and it becomes that size. Remember, black holes don't, that actually kind of does look like a black hole if you put into consideration of solar lensing. Nah, let's not even try. I don't know what I was talking about a second ago. Fuck. But I do remember one subject where basically just the space in the universe was so small and had such little volume compared to mass. I think that's right. That it just swallowed a fuck ton of matter all at once. And when black holes also swallow matter, sometimes they have so much shit surrounded in their rings that a beacon would be a good example. That it creates so much friction between the clouds. Say these guys are just scratching all along each other while being sucked into this black hole, that it would shoot a beam of light that would outshine the very galaxy that the black hole is in. Now, Ton 618, I believe, has a constant quasar due to how much mass it loves to consume. But I think that's pretty neat. Genuinely, I think that's pretty neat. And if y'all don't know, I'm trying to go into quantum theory. I'm trying to self-teach myself physics, and so I feel like trying to keep my memory steady of these things, or constantly refreshing my memory of these things, and posting it on YouTube or whatever is a good way of kind of reviewing. Although the black holes and the random facts aren't really part of quantum theory, quantum entanglement and quantum theory and quantum computing are things that I want to keep in my head, because I can already tell you that probably 80% of the things I've learned about quantum theory I've completely already forgotten about because it is such a complex subject and it is quite literally impossible to understand without mathematical capabilities, which I do not have as of this moment. So, hopefully, in time, when I expand my knowledge with quantum theory, I'll be able to explain it better. But for now, it's fine. And I would say, how long was that explanation? That was a 15-minute explanation, so I feel pretty comfortable with stopping a little lesson right there and just heading on to a realm. Oh. Seems like we're having an issue. I guess I'm going to restart the stream. I'll try to. Hopefully. Alright, I'll see you guys here in a bit. Sorry about the